There is a piece of paper sitting in a university archive. It is not much to look at. A computer printout. The kind produced in the 1970s, where numbers and letters scroll continuously across a page in long columns. Most of the characters on it are unremarkable. Ones and twos, occasional threes, the background noise of the universe, translated into alphanumeric code. But in one section of that printout, the characters climb. 1, E, Q, U, J5, 2, 6 characters, each one representing the intensity of a detected signal during a roughly 10-second window. The scale runs from 1 to 9, then continues with letters. 10 is A, 11 is B, and so on. A reading of 1 is barely above background noise. A reading of 6 is significant. A reading above that has never been explained. E. On this scale, that is 14 times above background noise. Q. 17. U. 20. J. 19. 5. 14. A signal rising to 20 times the background level of the universe, and then falling again in a perfect bell curve, lasting exactly as long as the telescope's detection window would allow it, to last for a genuine astronomical signal. And then gone. The scientist who reviewed this printout several days later did what scientists almost never do. He reached for a red pen. He circled those 6 characters, and in the margin, in his own handwriting, he wrote one word: wow. That was August 18th, 1977. Almost half a century later, nobody has been able to fully explain what that signal was, or where it came from, or whether it will ever come again. This is Deep Space Declassified. New classified file every week. Subscribe before we go further. Let's get into it. To understand why that printout matters, you need to understand what was being searched for, and just how specific the search was. In 1960, astronomer Frank Drake pointed a radio telescope at 2 nearby sun-like stars and listened. Not for weather, not for satellite signals, for anything that did not look like natural noise. He was looking for signs of deliberate transmission from somewhere other than Earth. The project lasted just a few weeks and found nothing unusual. But it established a framework that would define the search for extraterrestrial intelligence for decades. The logic was straightforward. If another civilization wanted to make contact across interstellar distances, they would need to broadcast a signal strong enough to travel light years of space and arrive at a detectable level. And they would need to broadcast on a frequency that any technologically capable civilization would know to look at. There is one frequency that stands out above all others in radio astronomy: the emission frequency of neutral hydrogen, the most abundant element in the universe, sits at 1420 megahertz. Radio telescopes around the world use it as a reference point. Any civilization with the ability to build a radio telescope would know this frequency exists. Any civilization deliberately trying to communicate would understand that this is the channel a listening species would be monitoring. At Ohio State University, a radio telescope called Big Ear had been listening to the sky since 1973. It was not a glamorous facility. It covered about 3 football fields. A large, flat, reflective ground plane with 2 tilted reflector panels at the end. No moving parts. Instead of rotating to track targets, it relied on Earth's own rotation to sweep different regions of the sky past its fixed beam, each region spending about 72 seconds in the detection window as the planet turned. Big Ear was specifically searching for signals at and around the hydrogen frequency. It had been listening for 4 years. It had found nothing unusual. And on the night of August 15th, 1977, that changed. The Big Ear Telescope did not have a recording studio. It did not have a bank of computer monitors displaying real-time signal visualizations. Data from its receivers was printed on continuous paper output, columns of numbers and letters running down the page as the telescope swept across the sky. The data was reviewed later by researchers going through the printouts, looking for anything worth noting. On August 18, 1977, 3 days after the signal arrived, astronomer Jerry Emin was doing exactly that, sitting with a stack of printouts from the previous days of observations, working through the columns methodically. And then he saw it. 6 characters that did not look like the rest of the data. Rising in intensity, peaking, then falling again in a shape that perfectly matched what the telescope's beam pattern would produce if a genuine narrowband signal from a fixed point in the sky were passing through it as the Earth rotated. The intensity was far beyond anything Big Ear had recorded in 4 years of listening. The peak value of U, 20 times background noise, was so far above the noise floor that Emin later said he could not initially believe the instrument had actually produced it. He reached for his red pen. He circled the sequence. In the margin, he wrote, "Wow." The signal lasted 72 seconds, exactly as long as the Big Ear detection window would allow for a genuine signal from a fixed point in the sky. No longer. No shorter. A signal arriving at its full strength, peaking and departing on a schedule that matched perfectly with the telescope's sweep, and with nothing on the ground, nothing in orbit, and nothing in the atmosphere that could account for it. And then it was gone. What made the WOW signal so difficult to dismiss was not just its intensity. It was the combination of characteristics that aligned with exactly what scientists had theorized a genuine interstellar signal would look like. First, the frequency. The signal was detected at 1420.455 megahertz, the hydrogen line, the exact frequency that every SETI researcher had identified as the most logical channel for interstellar communication. A natural narrow-band signal at exactly that frequency is not impossible, but it is extraordinarily rare. The vast majority of natural astronomical phenomena produce broadband signals across a range of frequencies. A narrowband signal clustered at or near the hydrogen line at the intensity the WOW signal reached had no natural explanation anyone could immediately identify. Second, the polarization. Big Ear was not equipped to measure the polarization of incoming signals, whether the electromagnetic wave was oscillating in a single plane or multiple planes. This was a significant limitation because polarization analysis might have helped determine whether the signal was artificial or natural. The absence of that data was not sinister. It was simply a gap that left one avenue of analysis permanently closed. Third, the shape of the signal. The rise and fall of intensity over those 72 seconds, from 6 to E to Q to U to J to 5 and back down, traced a curve that precisely matched the beam pattern of Big Ear's antenna. This meant the signal behaved exactly as a genuine point source in the sky would behave as the telescope's beam swept across it. It was not a spike. It was not a flat line. It was the smooth bell curve of a real, fixed, distant source. Fourth, and most importantly, no known natural phenomenon at that time. No pulsar, no quasar, no known interstellar gas cloud was documented as producing a signal with that combination of intensity, narrowband frequency, and smooth profile at the hydrogen line. It matched the theoretical profile of an alien transmission better than anything ever detected before or since. Ekman reported the finding. Big Ear's operators immediately began trying to redetect it. They pointed the telescope at the same region of sky night after night. The signal did not return. This was alarming for a specific reason. If the signal were a genuine narrowband transmission from a fixed point in space, and if it were being broadcast continuously, it should have appeared again every time Big Ear's beam swept across that region of sky. The fact that it did not appear again meant one of three things. The signal was not continuous, the source had moved or changed, or the detection was not what it appeared to be. In the years and decades that followed, dozens of radio telescopes around the world pointed at the same region of sky and listened. The Very Large Array, the Arecibo Observatory, the Parkes Telescope in Australia, the Robert C. Bard Greenbank Telescope in West Virginia. Breakthrough Listen, the most comprehensive SETI program ever funded, with over $100 million dedicated to the search, has scanned the region. Nothing. No repeat. No echo. No second detection of anything resembling what Big Ear recorded on August 15th, 1977. The WOW. Signal has been heard exactly once, for exactly 72 seconds. From a direction in the sky we cannot fully pin down. From a source we cannot identify. Using a technology we cannot verify. And in nearly half a century of looking, it has never come again. Where did it come from? Big Ear's detection gave a rough direction. The signal came from somewhere in the constellation Sagittarius, near a group of stars called Chi Sagittarii. But Big Ear's limited angular resolution meant the exact source could not be precisely pinpointed. The signal came from a region roughly 5 degrees wide in the sky, a patch containing thousands of stars. In 2016, astronomer Antonio Paris proposed a new explanation. He suggested that the signal might have been produced by a hydrogen cloud surrounding a comet, specifically two comets called 266P/Christensen and 335P/Gibbs, which his calculations placed in an approximately the right region of the sky at approximately the right time in August 1977. The proposal was published in a journal and received significant press attention. It offered a natural, non-alien explanation. The hydrogen cloud surrounding a comet can produce emission at or near the hydrogen line. If a large enough comet cloud passed through Big Ear's beam at the right time, it could in principle produce a signal above the background noise. But the explanation faced serious criticism. First, the comet clouds in question would need to have been extraordinarily large to produce a signal of the WOW intensity at that distance. Second, the signal's narrowband nature, concentrated very close to 1420 MHz, did not match what a comet's hydrogen is, which would be broader and less spectrally concentrated. Third, when researchers pointed telescopes at those same comets during subsequent passes near Earth, no signal resembling the WOW was detected. The comet hypothesis reduced the certainty around the WOW signal's extraordinary origin. It did not explain it. The question remains officially open. In 2020, Shane Telescope at Lick Observatory in California focused on two sun-like stars that fall within the rough coordinates of the WOW signal's origin. 2MASS 1928-1982, 2640123, and 2MASS 1928-4531-262152. Both are located approximately 1,800 light-years from Earth. Both are similar in spectral type to our Sun. The observation found no signal, no transmission, no electromagnetic anomaly of any kind from either star, which tells us something, but not everything. If a civilization around one of those stars was broadcasting a signal in 1977, that signal would have taken 1,800 years to reach us. To hear it, we would need to be listening at exactly the right moment in a window that opened once and may or may not open again. A civilization that transmitted once, on one date, in one direction, would need to be extraordinarily lucky, or would need to be broadcasting continuously for us to catch it at all. And if they were broadcasting continuously, Why have we not heard it again? This is the paradox at the heart of the WOW signal. Every characteristic of the detection is consistent with an artificial interstellar transmission. The frequency, the intensity, the duration, the profile. And every attempt to find it again has failed. Either it was a natural phenomenon that fit every artificial signal criterion by coincidence, or it was artificial and has not repeated. Or it repeated and we missed it. Or it repeated and it is waiting in data we have not fully analyzed. None of those options is comfortable. On August 15th, 2012, exactly 35 years after the WOW signal was received, the Arecibo radio telescope in Puerto Rico broadcast a response. Not a response in any meaningful communication sense. A response as a statement. A message aimed at the region of the sky from which the WOW signal appeared to have come, carrying information about Earth, about humanity, about the civilization that had been listening. The message included a binary encoded image of the solar system, Twitter messages contributed by the public from around the world, data about Earth's position and the nature of its inhabitants, a digital reply to a transmission that might have been nothing, or might have been the most significant signal ever recorded. If that broadcast is heading toward a civilization 1,800 light-years away, it will arrive in the year 3812. If anyone is there to receive it, they will not hear it for 17 centuries. Their response, if they send one, will not reach us until the year 5612. Long after every living person on Earth today has been dead for thousands of years. Long after every institution, every language, every nation that currently exists has likely transformed beyond recognition. The cosmic timescales involved in any genuine interstellar communication make the search simultaneously the most important and the most humbling undertaking our civilization has ever committed to. We are sending messages that our descendants' will receive a reply to, if they receive one at all, or we are not. And the WOW signal was a comet, and we are alone. Here is the detail that is easy to gloss past, but is worth slowing down for. The WOW signal was not detected in real time. Jerry Emmon was not sitting at a console watching it arrive. He was looking at a printout 3 days later, which means there is no recording of it in any real-time sense. No audio, no visual display captured in the moment. Just columns of numbers on a piece of paper, with one section circled in red ink by a man who recognized something that the equipment had faithfully recorded and that no one had checked for 3 days. The original printout still exists. It is archived at Ohio State University. The red circle is still there. The handwritten word in the margin is still there. Ethman's notation, made with a pen on paper in a moment of genuine scientific astonishment, is the most direct physical record we have of the most extraordinary signal ever detected by a radio telescope. And it is one piece of paper. If Big Ear had not been running that night, if Ethman had not been the one reviewing printouts that week, if the telescope's beam had swept past that region of the sky 30 minutes earlier or later, if anyone had decided that a 4-year search with no results was enough and shut the program down before 1977, we would not know the WOW signal had ever happened. There is no way to know how many signals we have missed. Big Ear itself no longer exists. In 1998, the telescope was demolished to make way for a golf course expansion on the Ohio State University campus, the most productive SETI instrument in history. The only radio telescope ever to detect a candidate extraterrestrial signal, was torn down to extend a fairway. The land where it stood is now part of a golf course in Delaware, Ohio. There is no monument, no marker visible from the road. A small plaque was installed by a local astronomy group, but it is not visible to people playing the course. The most significant detection in the history of the search for extraterrestrial intelligence happened on a piece of land that is now a golf course. Modern SETI efforts operate on a completely different scale. Breakthrough Listen, funded with over $100 million from technology investor Yuri Milner, uses the world's largest steerable telescopes to survey millions of stars across multiple frequency bands simultaneously. The Allen Telescope Array in California was specific SETI observations. The 500-meter aperture spherical telescope in China, the largest single-dish radio telescope ever built, is now capable of monitoring frequencies and sensitivities that would have been impossible in 1977. Any one of these modern instruments would detect a signal like the WOW immediately, in real time, simultaneously confirmed by multiple telescopes around the world. The infrastructure now exists to make a confirmed, unambiguous detection. If a signal arrives, nothing has. So, what was the WOW signal? The honest answer, after 47 years and hundreds of hours of telescope time aimed at the same region of sky, is that we do not know. It was real. The data is real. The instrument that recorded it was functioning correctly. Jerry Emin was a careful, methodical scientist who understood what he was looking at. The characteristics of the signal, its frequency, its intensity, its duration, its spectral shape, aligned with the theoretical profile of an interstellar transmission more closely than any signal ever recorded before or since. And it has never come again. The possibilities that remain are not comfortable ones. Either something natural produced a signal that coincidentally matched every criterion for an artificial transmission and then never repeated. Or something artificial produced that signal and never transmitted again. Or transmitted in a direction we were not watching. Or is transmitting right now and we are not pointing the right telescope at the right frequency at the right time. Or the WOW signal was a hello. A first word from somewhere we have never found, broadcast once into the dark, on a frequency that any listening civilization would know to check, at an intensity that crossed the distance between stars and arrived in the beam of a telescope on a college campus in Ohio on a summer night in 1977, and was caught on paper by a man with a red pen who wrote one word in the margin, and whoever sent it is still out there, still waiting, or gave up long ago, or never existed. Which possibility sits with you the most? Leave it in the comments. I want to know. And if you want to be here for the next classified file, subscribe and turn on notifications. Because the search has not stopped, and the signal is still missing.